Almost everyone knows the feeling of being completely stuck in endless traffic gridlock. It is a daily, exhausting reality of modern life. When city planners confront this issue, the default response is incredibly intuitive. If there are too many cars for the road, just build another lane. But the relief is notoriously short-lived. Barely a year after the new lane opens, the commute takes even longer than before the construction started. Our failures rarely stem from a lack of solutions. We often struggle because we apply our energy to the wrong problems. Reacting strictly to the traffic jam in front of you is operating at the event level. It is the equivalent of sprinting around putting out isolated brush fires while the arsonist holding the gas can remains at large. To accurately diagnose complex issues, we have to adopt a different framework: systems thinking. When we rely solely on linear cause and effect logic to tackle interconnected challenges, our common sense fixes frequently create entirely new crises. This illustrates the Iceberg model, a diagnostic tool to map complexity. Notice how the visible tip, the events we react to, represents a tiny fraction of reality. Lowering our perspective just below the waterline, we uncover patterns of behavior over time. Apply that depth to our morning commute. The gridlock is not a one-off accident. It is a highly predictable pattern occurring at the exact same time and place, 5 days a week, driven by mass human routine. Identifying that trend is crucial because it allows us to predict the next jam. However, it still fails to explain why the routine exists in the first place. At the iceberg's bottom, underlying structures dictate the system. This causal loop diagram maps the feedback loops. A city builds more roads. Briefly, driving is easier, but this triggers induced demand. Commuters abandon trains for the highway, adding drivers, leading straight back to more traffic. Now factor in physical geography. Smooth, wide highways actively encourage developers to build vast residential subdivisions far from city centers, permanently locking those residents into driving for every errand. Spotting this hidden architecture requires a cognitive shift. We have to zoom out and view zoning laws, public transit funding, and road construction as one single breathing ecosystem, rather than isolated departments. The system produces the exact results its architecture was built to deliver. Negative outcomes are the logical result of how the structures were constructed in the first place. Once you see the entire ecosystem, it becomes obvious that our initial starting point, asking, "How do we reduce cars?" was flawed from the beginning. The systemic approach forces a subtle but powerful reframing. How do we move people? Discarding the road expansion requirement makes a much broader range of urban design possible. You can optimize traffic flow using smart sensors. You can build out robust light rail networks, or redesign streets to prioritize a dense, walkable urban core that supports cycling. Reframing the question is the ultimate leverage point. It allows you to stop wasting energy fighting the symptoms and directs your resources toward redesigning the system itself. This mindset scales far beyond urban planning. If you want to eliminate massive food waste or untangle a global supply chain, you have to map the underlying structures driving the behavior. It is the exact same discipline required to integrate technological disruptions. Dropping a new AI tool onto a corporate team will create chaos unless you map how it interacts with their existing incentives and workflows. This methodology follows the principle that a system's behavior is determined by how its parts interact. Aristotle described this as the whole being greater than the sum of its parts. In a city or a company, the relationships define the outcome more than the individual nodes. The next time you face a persistent, frustrating problem, do not react to the tip of the iceberg. Pause, shift your perspective, and map the system.